In this video, we shall return to the general form of our equations for conic sections. And our goal is to identify the type of conic sections based on the equation. Well, there is such a thing as degenerate cases. But the examples of equations that I shall present here are the equations of your regular conic sections. What is the general form of a conic section? It is given by this: ax squared plus b times xy plus cy squared plus dx plus ey plus f is equal to 0. In our previous videos, we never had an equation where we had this term, the term for x times y. All the general equations that we had been studying are of this form. It does not carry a term for the product x times y. Our conic sections might look something like this. Its major axis or principal axis is horizontal, or it can be vertical. But of course, surely these are not the only orientation of the principal axis for an ellipse. We can have in fact an ellipse such as this, where the principal axis is slanted. And actually, this is the sort of an ellipse that will arise when your general equation carries a term for the product x times y. Okay, so we shall determine the type of conic section by inspection. That means by looking at the general equation, we shall state what is the type of conic section. For a parabola, it's easy. You know that for a parabola, only one term is a degree 2 term. X squared and y squared cannot be both present in your equation. So one of the coefficients of x squared and y squared would have to be equal to 0. If that is the case, then our equation would produce a parabola such as this. So this one, the coefficient of y squared is 0. So this one would be a parabola whose principal axis is vertical. It can either open up or down. This one is a parabola whose principal axis is horizontal. And so our parabola for this equation can either open to the left or to the right. How about for a circle? For a circle, the terms for x squared and y squared must both be there, but their coefficients must be equal. If that is the case, then our equation produces a circle. So this one is an equation for this circle. Look at the coefficients, they are equal. But you know what? The coefficients need not always be positive. They can be both negative and still they would produce a circle for as long as the coefficients of x squared and y squared are equal. How about for an ellipse? Okay, so for an ellipse, A is not equal to C, but it doesn't mean that A and C would have to be always both positive. They can be both negative. So for our ellipse, A and C must not be equal, but they must have the same signs. So if they have the same signs, positive times positive is positive. If A is negative and C is negative, negative times negative is also positive. So this one, A is equal to 10, C is equal to 1. They are not equal, and both of them carry the same sign. Both of them are positive. So this is the equation of an ellipse. How about this one? A is negative 4. C is negative 1. They are not equal. They carry the same signs. So, again, this is an ellipse. How about for a hyperbola? Well, you can already guess what it's going to be. A and C must not be equal, and more importantly, they must have different signs. So that means the product of A and C is less than 0. If that is the case, the equation would produce a hyperbola. So this one, A is equal to 1, C is negative 10, they are not equal, and they have different signs. So this one ought to give us a hyperbola. How about this one? A is -4. C is 1. They are not equal. They have different signs. This must be another hyperbola. I will show you some degree 2 equations in x and y, and we shall state the type of conic section judging on its general form. Okay, so even without writing this in the general form, you can tell right away that this must be a hyperbola. The coefficient of x squared is 9. The coefficient of y squared is -16. Different signs, so it is a hyperbola. Another one, 9x squared plus 25y squared minus 3x minus 25 is equal to 0. So let us pay attention to the terms involving x squared and y squared. Their coefficients are not equal and they have the same signs. So this should be an ellipse. How about this one? Obviously, this is a parabola. How about this one? 25y squared plus 25x squared minus 200 is equal to 0. This one can be an ellipse, this one can be a circle, but because the coefficients of y squared and x squared are equal, okay, and they carry the same signs, so this should be a circle. Now, there are conic sections which are called degenerate cases. And we cannot tell right away that they are degenerate case of conic sections by simply inspecting the equation in general form. We will have to write them in standard form, and the standard form will show that they are not our regular conic sections. We will devote a separate video presentation for that.